Hey everyone, we're back. I think I have a solution to the problem we were running into last week. Basically, we were trying to use the from trait in Rust. Actually, you know what? Let me just jump back into here. We can walk through this ourselves. So we were trying to use the from Rust trait and use this to convert an instruction into a token list, which is what Binary Ninja needs to be able to render out the tokens. We ran into a couple problems. One is that remote impls aren't possible. So I can't have a trait in one crate and a type in another crate, and then try to implement that trait for that type in a third crate. You can implement a trait for a type that is in your crate, but I could have sworn that remote impl was a thing that was going to get implemented in Rust and was at this point, but apparently it's not. The other issue we have is that for jump instructions, and I'm going to pull this up real quick. Let's see, I think it's this one. Yep, new window. So for jump instructions, the values that are in our offset here are all going to be relative offsets. So they're number of words that you go forwards or backward, and that's fine. It's good for encoding instructions because it's small, and you can do a lot with less bytes because you don't need to be able to support the full 16-bit address space in the values that you can put there. So it's really good for encoding. But when you want to actually make addresses that are relative to your current location, you don't know that. And part of the problem with the from trait, is that you can't provide additional information. Now there might be a different from trait that you can do like a from with or something like that. I don't know. But overall, it didn't seem like it was going to work out. What we are doing, I'm going to bring us back to the code here, is we are building a series of functions that will handle the printing for us. So basically, we're just going to kind of like an inverse recursive descent parser. This is like a recursive descent printer. We have this generate tokens, and the token, it's going to figure out what kind of token it is, call the right function to print that kind of token, and it will call any additional functions that it needs to kind of do that. So we'll probably build a function that handles source operands, destination operands to properly print them, so that anything in here that uses a source or destination is capable of reusing that code. I'm going to have to copy it, but overall, it's pretty straightforward. The other big thing we're doing is we're using impl traits, which is something that came out with Rust 2018. And basically what this allows us to do is, before impl traits existed, you were unable to pass effectively like a trait object to a function or return one. If you wanted to, say, pass anything that implements this trait, you had to box it and perform that type erasure. And part of the reason is because that a trait itself does not have a size, so it doesn't know how much to allocate. The impl trait does away with all that and makes it easier. Under the hood, I'm not exactly sure what it does, but it does work. And so we can see here that, for our generate JXX tokens, we're passing an impl JXX. Last time I streamed, or after the stream, I implemented a trait for jump instructions, and I think that's the approach we're going to end up taking, is building a handful of traits for different types of instructions and using this. So the trait ends up being just 3 functions. We have a mnemonic, which we're going to use for printing, offset, and len. And in our macro that we do all this in, we just implement the trait for it, because these are all generic. They're just pulling out values that are part of the type. One thing I am curious about, though, is if we can put these values in the traits rather than in the individual types. And I'm not 100% sure if we can do that. Member. So you can do these types, but that's not really what we want. Yeah, I think you can only do associated types, so not exactly what we're looking for, but that's fine. We don't need that. So now the question comes: do we want to do single operand or double operand first? Because both are actually fairly difficult. I shouldn't say difficult. They're both much more complex than jump instructions, which is why we did jump instructions first. And the reason being is that jump instructions don't have operands in the sense that they don't have like a source or a destination operand. They have their own special encoding. But for both the single and double operand type instructions, they have those, and double operand instructions are going to have all the special logic for figuring out if it's an emulated instruction or not, and that complicates it. And for single operand, there's actually two types of single operand instructions. You have single operand instructions that have that come with a width, so you could do like what's like one of these that we can grab really quick. Swap byte.b, which says the operand I'm using is going to be just a byte, not a word. And so we have to kind of and they're going to have different methods as well. So we got to figure out where we're going to go. And I think the easier place to start is with the single operand, because the emulation is going to be a little bit more difficult. And the question is, we want to create two different types, two traits. One that's a single operand with, which is a kind of a weird way to say it, but it's width, and then single operand just like regular by itself. Or do we do a has width? And we just decide that. Maybe that is the move, is we do a has width. Let's see here. We can say that it has a source. Size. Yeah, maybe this is the way to go. Impl. I also did a little bit of renaming as well. To make it a little bit clearer, and we created this new type, operand width. It's just an enum, or not operand. Yeah, operand width, which is an enum of byte or word. Make that pub and not screw that up. operand width. And simple t impl has width for t, and we just copy this out here. So I wonder if you can do an implementation in our trait. Rust trait oh, you can. Oh. Yeah, so you can only do it with methods. So it requires that you you define methods on them, which is kind of unfortunate. I think like Java instances or interfaces, you can do that. Because the nice thing would be if we could create a contract where like we just make sure that these types have the member, and then these can utilize it, but or that the interface can provide the method, but or the member, but you know, this is fine. And then ret_i, we need to implement single operand. Ooh. I think that's gonna end up being a special case, and that's fine. So let's go back to here. And let's see. Single operand tokens. And this would be we'll clean up this stuff in a little bit, but so that's single operand. And do we have any of these traits defined anywhere in here? I think we do. No, we're good. Okay. So now basically the big thing we got to do here is I guess the question is, do we want to add the mnemonic method to this or not? And does it make sense to get rid of it altogether? I guess here. It might. I mean, like we can do a pretty simple match statement. We're going to match the instruction. So we end up doing instruction token. And then it becomes format. Why are you so angry? Ambiguous plus in type. I wonder if I have to define the type. Do I need parentheses around this? No? It needs to be before the impl. That's why. Okay. So we get our mnemonic. I think I'm going to go back and I'm going to do that probably for the jump ones as well, because there's no reason to have it implement the method there. Like, we're probably not ever going to use that. Will it format this better? Nope, it won't. Okay. So that's fine. The next thing we need is an instruction text token. New. Oh, no, actually, we don't need that. What we do need is generate source token inst and this ends up being like effectively the same thing. The only difference is that you know what, we'll do this after, because we're gonna have to do a little bit more logic to get the right value for whether or not there's a byte there or a word. But we do need to generate source tokens. And it's gonna return a list of tokens. And it's going to take source All right. So we're good there. Inst source. So we're going to pass in the source here. And what this is going to let us do is pass this for the double operand. But I don't know if we're going to be able to actually, I guess we could. The only difference is going to be whether or not we bail out early for a emulated instruction. So I think what we end up doing is we do just a big match arm. And then depending on what the match is, we end up returning a vec there, because each one is going to be somewhat different. And we actually can already do this. We have most of this code, we just have to churn it into something else. If we go to Operand, we can go to source, and we can go to the display implementation for it. And so rather than all these writes, we're going to end up returning basically just a vector of the thing that we're trying to do. So in this case, it ends up being a vector of instruction token text new. This is a register, and in this case the text ends up being, actually do this. I think that works. The one thing we do need to make sure is that we are passing in the right value. So that would be here, and then instruction text, token, content, and register is just a register. So we're going to pass in the string representation of it, and that's fine. And these ones are going to be a little bit more painful because we are going to have to do these independently. Just because of all the negative numbers and everything. But that's fine. So this ends up being contents. So the first thing we do is a number. Integer. And this ends up being I, which are we gonna do? Is this supposed to be the raw like bits? That's what I don't understand about the integers here. Is what they're supposed to be. We can go to the implementation of this. So let's see here. So with the matching contents, and what is contents here? It is the, so this ends up being the thing that we send in. If it's an integer, then we change the res value to whatever's in there. So yeah, I wonder if that's just supposed to be the actual bits. This is what I don't understand though. It's like if you're doing an integer like this, you're gonna lose the size. You don't get to do. There's a getter but not a setter for size, and you don't get to control the size. So Yeah, I mean, is this just the raw bits? I mean, I guess we put in. I guess we can put in the value here. And then this ends up being actually I, but we need to format it. Wait. So we end up formatting it with that. I'm like running out of space here. That's better. Just can't see this stuff. All right. Okay, so there's that. U64. So we end up doing that, and then we have like a text token. New. And it's just text, which is that. Yeah, okay. Text token, new, contents. Then we have a register, which is SP. Then instructor text token, new. Text. Yeah, okay. So then this becomes like what we want to print. And then in this case, it's effectively the same thing. And the reason we're doing this is because there's no negative formatter for hex. Yeah, okay, so that makes sense. In which case, the only difference here is this is one of those situations where maybe we want to make this mutable and then just like build it. Hey, Fufkies. Honestly, I switch between a bunch of tools all the time, so I would say get familiar with a bunch of them and use whatever makes the most sense. I think I've mentioned this a few different times, but most of the tools are good at some things and bad at others. For instance, IDA has a really good decompiler, if you can afford it, and it supports a shitload of architectures. The disassembly is actually very good for most cases, but it's particularly bad when it comes to embedded stuff that doesn't have like a real file format. So if you don't have like an ELF or a PE file or a Mako, it trying to figure out like what's going on is actually pretty bad. Ghidra, on the other hand, is really good at like firmware. Decompiler is pretty solid. I think the UI is a pain in the ass to work with personally. It's kind of slow and like support is good for stuff, but like there's some of the more like weird shit like you're not gonna see. Binary Ninja is great if you want to do like algorithmic access, so you want to be able to like write code to do analysis. The multiple levels of IL are really interesting, and I think there's a lot of like optimization you can do there that we haven't quite seen yet. But out of the box architecture support is not great, and there's some limitations in terms of what it's capable of doing. But the API is really nice. And then R2 is just like if you want to pipe shit away into other stuff, like it's great for that. It supports a lot of stuff out of the box. It can run on basically anything. So yeah, I mean, I'm very comfortable with Vims, but I can understand what you're saying. Like it's a pretty steep learning curve. I'm by no means like actually very good with R2, but I'm good enough that like I can move around and do some like of the stuff that like you would need to do for a lot of like the basic stuff. There's a new project called Ryzen. It's a fork of R2, and they're doing a bunch of stuff. Like they've already made some changes to the project management, which was awful in R2, and so this is a lot better from what I've heard. I haven't played with it yet. Not really sure what else is on the roadmap, but I'm excited to see like what happens. From what it seems like, they want to make things a lot more stable and less like painful to learn and figure out. So I don't know. One of the things that really bugged me about Radar is like things would change out from under you at any point in time. There was no consistency. Like arguments weren't consistent. Like they might swap the ordering of like your source and destination, or swap the ordering of like where the address is or whatever between different commands. And so I found it really frustrating. Oh, this is so annoying. I think we're gonna go ahead and do it this way. Oh, but yeah. One. And it ends up being that. And that is correct. I'm gonna go here. We can copy this out of this. And it ends up being the same thing with the negatives here. register, and then this just becomes R. That's not what I want. That is what I wanted. So this should do the register index. We have register direct. Vec. Text. There we go. Really, we left the rights there. We gotta just rip that out. This ends up being format. All right. Yeah, okay. All right. Copy that. And it ends up being plus that, and then instruction contents, text plus, yeah. This is another one of those like negative things with support. Which I think this is right. I don't know if we've ever actually seen this used. I think we can do a similar thing. So we end up doing that. And integer, this ends up being I as use 64. And this becomes numtext. And then we have text token, we have another text token, and in between here we're going to have PC. And I think that's right. And then this ends up being we need our pren. So this gives us our negative number. We gotta go back and fix this at some point. Maybe we build a different trait, or we try to add a different formatter. I don't know if it's possible to like add our own formatter, but it's something we're probably gonna want to do. Like, this is just super frustrating that we can't get this. This one is really easy. It ends up being vec token new text instruction text token contents. This ends up being A as use 64. And this ends up being format. I always hit that button. I never want this to happen. A. Right? That seems right. And then we just have these last two, and seems correct. There's no rights in here, are there? We got them all. So we got to do immediate and then auto increment. These should be pretty straightforward. Let's see. Text is that. We have some of this already, don't we? Yeah, it's right here. So we have that, and then we have integer, and it's just that. Okay, that seems correct. And then our constant is effectively the same thing. All right. So looks like we have a few issues. Pub is not permitted here because it's implied. So single operand, we have to go back to our this crate here. Single operand, line 34. Okay, yep, we don't need that anymore because it is given to us. And then for source as well. And operand width. Okay. Lots of casting issues, which is fine. And the other thing we need to do is we need to fix some of this. No rules expected. The instruction text token. This is 527. I forgot that. Expected struct. Right. Because we need to combine those, which is straightforward. Rust vec. I think there's like an extend. Extend from slice. Yep, that's it. Expected. Does that not work? What? Oh, okay. Okay. So we're mutable, we can do all that. Let's see. Now we just have all these type errors. Expected type parameter, impulse single operand, and found that. Single operand. So this is a special case. We're basically just going to do this for right now. Instruction. And it's... instruction. Why are all these mismatched? Right. This is not correct. These should be or single operand. How do we do this for jumps? So I think this is the change we need to make, is just this. All right, so there we go. So I think we can do into. If not, it's to owned. Yeah. Use struct. Single operand RC. Expected unit struct, unit variant, or constant found. Can we not match based on? Well, let's fix these things first, because these are the easy ones to go through and do. Cannot cast an I8 as a U64. So what is this? This is at 571. These just have to be dereferenced. I think. It's 555. Yeah, and this is 545. This is 528. 487. I guess these don't have deref implemented for them. So 472. So this is what, 460. $448. All right, so that's all fixed. 554. Instruction. Oh. So 509. Yeah, it's all of these just have to be into, because they're all stirs. There used to be a time when in Rust there was a big difference between doing into and to owned, and then they changed it and made an optimization, and I think it's exactly the same now. It looks like we can't match on type, which makes sense. There's no runtime reflection or anything. That's probably why you use enums. Expected it unit struct, unit variant, or constant. So maybe we do need mnemonic. Maybe we need mnemonic, and then we pull it out with that. Wonder if you can do this. Like, can you do vec this is like a Go thing. I wonder if you can do this. Nah, you can't do that. That'd be cool if you could. All right. I guess because it wouldn't do it at it would do it at runtime. All right, so we need generate single token inst. Push. I think I screwed that up. Which ones are you allowed to do? Call doesn't have width. All right. So I guess that is the way we have to go, because we don't get to do this nice little thing here. And it means we have to go back to here, and we have to define a method called mnemonic. And it would be in single operand. Yeah, so self, oh, no, it would just be, n. Okay, that's fine. Cool. Let's see if this ends up working. Source. Copy. So we should be getting a bunch more instructions now, assuming nothing like dies. It's looking better. That's interesting. Okay. So it seems like it's working. We're getting everything kind of spit out properly. I'm seeing negative values, but you know, I don't know how many there are. It's possible that we just don't have any. That's interesting. That is. Oh, this is text. That's why. This is. This is treated as text. How do you do that? It's not in code. How do you do this? It's not code. I want it to not be code. Do I have to turn it into a not function first? So, that's pretty good. I'm gonna go ahead and shift this really quick to the webcam view. I want to log into microcorruption just so I can verify that what we're seeing is what we expect to be seeing here. And then I think that it ends up being pretty simple to do the other instructions, the ones with the bytes there, or possible bytes. 4414. Okay. 443A. 4B66. Yeah. This is 44C0. R15. Yeah, we're good. Okay. So, oh, you didn't see any of that. So I'm just looking at like decoding here and making sure that everything lines up here with here. I think that our decoding is actually more correct than what's in here. But yeah, we're let's go see if we can switch over to here real quick. And I think that we can implement the to-operand as well pretty quickly. It ends up being almost exactly the same code. Actually, actually, I wonder if we can do it so that we just have mnemonic implement it for us, and then we can reuse the same one. So if we have mnemonic here as well, I wonder which one takes priority and how it differentiates. Basically, no, we would just do it here. Okay. Self operand. I'll just do a match. Word. Right. N. I guess, can we concatenate strings in this or not? Kind of think it's not possible. Does that work? I mean, we don't have to, I guess. So if we do... Just like, can you do this like you can in, Let's see if this works. So it'd be here. That seems to be fine. Let's close that, and we're gonna do that. I don't know if it will do the replacement inside of a string, but it should, I guess. No, so it's not doing the replacement. Just macro replace in string. Use attribute in string. Is it just :expr? like I don't want to create the string, and I shouldn't have to. Syntax. Arguments. Just macro. Like, I can't do this. This does not work, I don't think. See, I don't want an own string, though. I want RISC macro string argument interpolation. Let's stringify. An expression of type static stir, which is the stringification of all tokens passed to the macro. No restrictions are placed on the syntax. Okay, yeah, it is what I want. Discard. And so this should get us, I think, the right value. What? Close. Is it just that? I think it's gonna still have quotes wrapped around the text. Yeah, so it's close, but not exactly. Rust combine macro argument with static stir. Oh, concat. That's exactly what I want. Be here. Okay. Discard that. We're going to copy this over. That looks pretty good. So let's go verify again that this is all correct. This is 450C. RRC. Did I screw that up? I might have done the backwards. No? Did I figure out these things wrong? msp430 instruction encoding. No, that's not what I want. This. RC is width. Single operand tokens. Mnemonic. I might have swapped these by accident when I did decoding. Operand width. Operand width. Yeah, these are swapped. Okay. That looks perfect. I think this ends up being like a printf or something. But yeah, I mean, it's pretty good. So because we don't have the instruction info correct yet, and it's not creating we're not handling the branching properly, we're not going to get basic blocks, but like we're getting instruction printing and it's all correct, it looks like. There's a couple bugs we still have from before, but we're going to fix those later. This is 4.5. Yeah, I mean, like, we're right here. It's all look good. We don't have the 2 operands done yet, but the big thing is figuring out what the right values are and handling this, because these are probably still wrong, and we'll get those fixed. And this is still a special case. We may be able to move it into here. I'm not 100% sure. I need to figure out whether or not it's a problem, but this is also fine. It just works. And yeah, I mean, the next big thing is doing the 2 operand instructions, and because of how we implemented this, I think it will be pretty simple. I think that, I mean, what we ended up doing, so the 2 operands will all be at has width. And we'll have to update those, which we can actually probably do now. So they're gonna get a has width, and we're just gonna make a trait, 2 operand, and they're gonna have source, destination, and len. I might end up doing a len trait, just so that we can pass things around a little bit easier, but I don't know if we even need to. Simple 2 operand T. And we need mnemonic. And this is the part that I think is going to get a little more difficult, is we're going to have to encode all that information. Return a stir. And this ends up being mnemonic str, and it just returns name. These pubs go away. Has width. we're gonna move this out to here, I think. Maybe just to here. I don't know. Single operand. Oh, it's not hash width. Operand width. We gotta get rid of this. Two operand is 38. Can we not do that? We don't have names for these. Interesting. Okay. N expr and this must be because we didn't end up using it because all the logic is built into this. And we can utilize this to grab it out of there anyway. That's fine. All the tests fail because they're all expecting a hard-coded value there. All right. Comma space. we'll fix this a little bit later, because I think I'm going to wrap this up in a few minutes. The one thing that I think we'll end up doing is just putting in some placeholder code for 2 operand instructions. So we won't support the emulated yet, but we can really quickly add support for 2 operand tokens, I think in about like 10 minutes. Extend from slice, generate, destination, tokens. And basically all we have to do is go and grab operand and this. Instruction text token, new. PC. This ends up being SP. SR. That's CG. And then R. Cool. So that's part of the way there. And then this I think we can like just straight out copy from here. Where's indexed? So PC SP SR. Maybe we can't just copy it because there's some differences. So this ends up being I comma text and this is a register. So this ends up being something we can copy just across here. And that becomes CG. That's SR. This is SP. And then PC. So this should be the default implementation for all of these. Two operand tokens, inst. So we're not going to have emulated instructions yet, but this will get us like basically to where we're at with printing for the current plugin that's written in Python. Just in terms of printing, not handling like you know, all of the the graph stuff you get from like branching or the lifting. So I think the next day we'll probably spend working on getting the emulated instructions finished up. I think I'm gonna wrap this up in a few minutes, but now this ends up being 2 operand plus has width Are we not using has with anywhere? Unexpected reference to operand. Did we not export it? To operand. That's there. It's a private trait. Has widths private. It's definitely there. Oh, because it's an operand, that's why. Right. Right. $431. Why can't you figure out the type? What? What do you mean a type annotation is needed? .431. How does it need a type annotation? It's this method call resolves to T. Do these not need to be .465? That's so weird that we don't need, I thought we needed the intos. So theoretically, we should just get everything in here now. Except for it won't be emulated, but we'll have everything. Oh, the one thing I forgot. To Operand. Contents, a separator. Why is the problem? Cannot. Oh, res. All right. All right. That's looking pretty good. This is not correct, but I'll fix that later. I'm going to wrap it up here. I got some cleanup to do, which probably will happen before the next stream. But yeah, it's looking pretty good. Anyway, I'll see you all next time. Maybe later tonight, maybe tomorrow. Have a good day, everyone. Bye.